Hey everybody, welcome back to chemistry. So if I can increase the slide, it reads as follows. Tin has 10 stable isotopes. The heaviest, 12410, makes up 5.8% of naturally occurring tin atoms. How many atoms of 12410 are present in 24 grams of naturally occurring tin? And then there's another question is, what is the total mass of the 12410 atoms in the sample? Okay, if I can lower the slide. So this is a bit of a difficult problem, and one issue here is that they didn't really give you all the information that you need to solve the problem. And so one big issue here is understanding what the 5.80% means. So what we're kind of used to in chemistry, when you see a percentage, that's going to be a mass percent. So for example, if you have a compound and you're told that it's maybe 58% iron, then you know that if you have 100 grams of that compound, then 58 grams is going to be iron. But the problem is, in this problem, it is not a mass percent. It's actually a percentage of atoms, and that affects how you solve the problem. So we'll have to keep that in mind as we solve the problem. So let me just do the first part. It says, how many atoms of 12410 are present in 24 grams of naturally occurring tin? So one thing I need to get is I need to get the molar mass of tin, so let me grab that here. So it is here, it's atomic number 50, and its molar mass is 118.71. So let me write that here. Molar mass of tin is going to be 118.71. So let me talk a little bit about what that means. What that means is that if you have 1 mole of tin atoms, it's going to have this mass. So 1 mole of tin is going to have a mass of 118.71 grams. And so from this equality, you can set up some fractions. So you can have 1 mole of tin over 118.71 grams, or 118.71 grams over 1 mole of tin. Let me just add tin here to the grams of tin. Okay, so also something very important to point out is that this molar mass of tin, this is for tin that occurs in nature, which has a lot of different kinds of isotopes. But what they're trying to figure out here in this problem is they're trying to figure out if you have a certain mass of this natural tin, how many atoms of this particular isotope, the 12410 isotope, do you have? Okay, so what I want to do is sort of design a strategy to solve the problem. So we're starting out with 24.0 grams of tin. So I suggest that you get this into moles of tin and then get that into atoms of tin. But then what you have to do is they don't want so much atoms of tin, they want atoms of a particular isotope of tin. And so what you have to do is using that percentage that you're given that problem, convert atoms of tin to atoms of that particular tin isotope. Okay, so let's go ahead and try this. So 24.0 grams of tin. And so let's first get this into moles of tin. And so the moles of tin, so we use the molar mass here. We're going to use one of these fractions. It looks like the fraction I want to use is the first one. So it's 1 mole of tin over 118.71 grams of tin. And so what you can sort of see at this point is that the grams of tin cancels out. Okay, now what you need to do is get this into atoms of tin. So you use Avogadro's number. So we're going to have 1 mole of tin here and Avogadro's number. And then at this point, you can sort of see that the moles tin cancels out, and now you're at atoms of tin. And so the final step is you want to get this atoms of tin into atoms of this particular isotope. And so that's where the 5.80% comes in. So let's go ahead and just figure out the total atoms of tin, and then using 5.84%, we'll figure out the atoms of the 12410 isotope. So you can go ahead and do this on your calculator. 1.2175 times 10 to the 23 atoms of tin. Okay, so you can take this number and take 5.8% of that, and that will give you the atoms of the particular tin isotope. So how do I do that? I take 1.2175 times 10 to 23 atoms of tin, and then if you want 5.8% of this, you have to multiply by the decimal equivalent of 5.8%, and that's going to be 0.058. So I multiply this by 0.058, and what I'm going to do is just take this number and multiply by 0.058, and I get 7.06143 times 10 to the 21 atoms of the tin isotope, so it's 124 SN. But they want this answer to 3 significant figures, and so I got to round this to 3 significant figures. So the answer should be 7.06 times 10 to the 21 atoms of this tin isotope, which is 124 tin. Okay, so we just solved the first part. Let's go ahead and solve the second part. It says, what is the total mass of the 124 tin atoms in the sample? Okay, so I'm going to create some room here. Okay, so just to note, this was part 1, and now up here I'll do part 2. So pretty much what I want to do is I want to figure out what this mass of these 124 tin atoms are. And so this is a little interesting. So you take 7.06 times 10 to the 21 atoms of the tin isotope, and they want to know what the mass of this tin isotope is. And so let's first figure out a strategy. So I would suggest that you take atoms here and get this into moles, and then moles into grams. Okay, so let's go ahead and try this. So it's 7.06 times 10 to the 21 atoms of the tin isotope. And we're going to get this into moles, and so you need Avogadro's number. So, all right, 1 mole of 124 tin over 6.022 times 10 to the 23 atoms of 124 tin. So at this point, the atoms of 124 tin cancel out. We're now at moles, 124 tin. Okay, so now it gets a little bit interesting. We have to get this into grams. And so what you might sort of assume is that to get the moles of this isotope of tin, the grams of this isotope of tin, you would look up the molar mass of tin. And unfortunately, that is not correct. And the reason is because the molar mass of tin refers to the average mass of all the tin isotopes. But in this particular problem, we're dealing with one particular isotope. So if we can't use the mass of the tin atoms in the periodic table, which is, I guess, 118.71, what do? What you can do is this. If you have a mass number for a particular isotope, that value is going to be very close to the molar mass of that particular isotope. So here we have a mass number for this tin isotope. The mass number is 124. And so we would predict from this rule that the molar mass of this tin isotope is going to be about 124 grams per mole. So here what I'm going to do is I'm going to write 124 grams of the tin isotope over 1 mole of the tin isotope. And now what you can see is that the moles of the tin isotope cancel out, and so now we have an answer in grams. So if you do the math and you round the correct number of significant figures, what I got was 1.45 grams of this 124 tin isotope. Okay, well, thank you for listening. We'll see you next time.